All right, thank you. Yeah, so my name is Paige. I'm the founder of Nyoka Design Labs. And as Ryan mentioned, I have invented a bioluminescent non-toxic glow stick. And that started by creating a light source that was, amazing and it gets people excited. My background is in biotechnology as well. And then when you throw it out, it's actually healing for the soil microbiome. A lot of my background research has also been in biochar and indigenous microorganisms. And so I love the opportunity to talk about just how important the microbiome is. And sometimes I call myself, an unofficial spokesperson of the microbiome. And I'm sure we all can relate here, talking about things that don't quite make it into kind of modern cultural discussions that we are all kind of ambassadors for this research and this work. So I'm always looking for ways to get people excited and then kind of hit them maybe where it hurts with some terrible information about ecosystem fragmentation, and then also provide some hopeful examples of some amazing technology and tools that we can use to make a much better world. And so that's what I'll be talking about today. It was hard to choose just one topic to talk about in 10 minutes, but I figured the best one for a Living Soil Symposium would actually be talking about our roadways. And yeah, just a bit about me here. So again, if you want to connect after this talk, I love discussing like indigenous microorganisms, biochar, biotechnology, and environmental restoration. All right. So I'll start with talking about the problem around ecosystem fragmentation and impermeable surfaces, specifically the millions and millions and millions of kilometers of roads that just cut across every continent on the planet, how that impacts ecosystem regulation, specifically with a lens on climate change, and then how we can start to actually heal some of that damage, and then some ideas on how we could potentially work together on these problems. So I'm actually joining from Canada, but I know this is in New York. So this is a kind of overview of just how much roadways cut across living ecosystems in the United States. So as you can see here, as you zoom in, there's just more and more and more roads. And roads are often, paved using concrete and asphalt. And when a road is created, the land is just dug into and cut apart. And so you can think about these roads as actually carving up ecosystems into distinct fragments. And this fragmentation is exactly what I'll be focusing on today as quite a dangerous phenomena that we are creating with all of these impermeable surfaces. So this is the total area of the world's roads, if you were to line them up and stack them together. So this is my home here in British Columbia. It's actually a massive province, over 600,000 kilometers squared. And that is basically a complete dead zone. And then you think about that, cutting across continents like all over the world and creating those fragmented ecosystems. And so if there's one thing you leave with today from this talk, it's that connection equals cohesive adaptation, specifically in the face of climate change. So there's been some amazing research out of the University of British Columbia, which really goes into the ways that trees and the soil microorganism network function as this kind of cohesive unit to respond to change. So for example, if there is a new disease hitting one side of the forest, plants that are able to adapt and respond and prevent the damage will actually send information to the other parts of the forest so they can preemptively prepare to prevent getting ill as well. And that's just one example of many about how ecosystem connection actually helps ecosystems adapt and stay healthy in the face of constant change. And specifically around climate change, so the rate of change is rapidly increasing due to our changing climate. And the rate of change is exactly what we want to be able to adapt quickly and positively to. And so by creating these fragmented landscapes, we're specifically reducing the overall land's ability to adapt to this change, and potentially will fall behind when we really want to create a strong and thriving and well-connected ecosystem that can survive in the face of all of this change and environmental degradation. So I'm probably preaching to the choir here, but just thinking about soil as like a massive, decentralized, dynamic organism that is crucially important for nutrient cycling, atmospheric regulation, homeostasis, you know, trillions of species in terms of like bacterial and archaeal are not even studied yet, and they're all incredibly important for life here on Earth. And the disruption of these cycles, not only impacts the soil and these species, but it impacts ourselves as well as we're dealing with, ecosystems that are failing, requiring much more like care to even have a like functioning land. And this is a graphic that I use that I think really kind of ties in this concept of fragmentation and what it does, where you can imagine that the red is the underground kind of mycelium network that could be connecting, huge ecosystems. And then the areas such as roads and development create these dead zones where we have these islands of disconnected units. And that can be pavement, that can be monoculture, that can be like cities and towns, and anything that cuts apart ecosystems and limits their ability to retain that interconnectivity. And getting a little bit down into population genetics, one of the dangers of fragmentation is that it actually reduces the ability for evolution to move forward in a beneficial way, where when the population size is low, you'll actually see more of a trend towards randomness, where beneficial mutations will not become standardized and move forward in a population. And so by creating more fragmentation, not only are we reducing the ability to adapt, but adaptation takes place in a way that may not even be moving us forward in the direction that would be beneficial overall. So I'd love to go more into detail about this as well. But there is good news, as there are many things that we can do to prevent this ongoing destruction. And, I'll go into this in the further slides. So number one is to protect and conserve old growth ecosystems, which exist as kind of this time capsule of what a mature and highly connected ecosystem looks like. These ecosystems are highly at risk, not only because they're highly valuable in terms of the mature wood. In BC, agricultural, clear cutting of these ecosystems is constant. And I'm just a couple weekends ago, I was part of a blockade to prevent some of the 1% of old growth forests from being clear cut here on Vancouver Island. And again, a lot of these sites are part of Indigenously managed land, which again are under more risk for land that's being taken from the Indigenous peoples and then is being just destroyed. So a lot of what we can do is to campaign to protect and conserve these ecosystems and see what you have locally. Almost every different ecosystem around the world is worth protecting in terms of these like mature and undeveloped lands, and they're just treasure trove, not only of understanding and intelligence, but also in the field of biotechnology, so much innovation comes from discovery in these incredibly biodiverse and mature ecosystems. Second is to use permeable paving. And so permeable paving, I do some work for a company, and this is just one company here in Canada. And over the 10 years they've been in business, they've kept over 2 million square feet of the earth alive by having a completely permeable paving system instead of concrete and asphalt, where water cannot get through and life cannot survive underneath. And so that is a huge way that we can prevent the fragmentation, as well as limit stormwater damage, reduce heat island effect, and a number of other beneficial services, both in the city and in rural areas as well. And the last one, this is something that I'm just starting to work on, which is to actually start reconnecting the underground mycelial networks. And so this is a project that I did with a friend, where there was going to be a pathway installed, and we actually dug a trench and put an inoculated log underneath so that there would be a protected mycelium network to reconnect the ecosystem that would have been completely disconnected with the application of the concrete path. So yeah, my wish is that every hardscape, could be transitioned into a permeable one, and to also make these underground bridges just as kind of normalized as some land bridges are becoming for larger creatures, to enable those adaptive ecosystems to remain connected and ensure that evolution continues to go in a more beneficial direction into the future. There are some, I would love to be able to, tell you that this research, you can like exactly measure the rate of adaptation, and if it's meeting the rate of adaptation required to match with the rate of climate change now. And that's something that I'm working on. So there's this amazing open source data bank called the National Ecological Observatory Network. And it's one of the first in the world that is looking at the soil metagenome across ecosystems and across time. Right now, they have about 2 to 5 years of data for each of the 16 sites that they're monitoring. But over time, this will become a benchmark that we can use to measure those rates of change, as well as biodiversity of the microorganisms. And secondly, the MIT Climate CoLab has an open call for solutions that create more adaptive ecosystems. So I'm working on an application right now, and if anyone else is interested in learning more about that or becoming involved, I would absolutely love to chat more and stay connected about this work. And that's about it. I'm so inspired by everyone here. Thank you so much for having me. And if you want to take a picture, these are some of my links, and it would be great to hear from you and to stay involved. So thank you.